Good morning, ladies and gentlemen. Today we are doing the final section of the naming of ionic compounds. This is, in my opinion, the easiest of the three types that we've done so far, just because there are no tricks. The rules with the charges are exactly the same. But for these, you will always be given a table with the list of polyatomic names just because you can't really answer the questions without them. You would just have to memorize them. So this is the same as the previous two sections where we've done naming with simple ionic compounds, we've done it with the transition metals, and now we're just doing it with polyatomic ions. And if you remember from math, polynomials, poly in general just means more than one. So what a polyatomic ion is an ion that has more than one element in it. So these are not um, single individual elements anymore. So we're going to be they're groups of atoms that are together that act as a single unit. Okay, so this is an example of a polyatomic ion. These are three examples: carbonate, nitrate, sulfate. And notice how these end in ate. So with the single elements, so nitrogen, for example, if we had n minus 3, which is what it would be, n minus 3 would be, when you put it in a formula, it would be nitride. Instead of nitrogen, it becomes nitride when you put it in element name. Okay. This is not nitride, this is nitrate. Okay, so these are not the same thing. This is a polyatomic ion. This is just a single elemental ion. Okay. So just pay attention to the name endings because you're gonna see some of them are similar. Okay. So in total, the three endings that you have seen have at this point are "ide." You just saw the new ones now are "ate." And then there's one more you're gonna see in a second, which is "ite." Okay. This one is for the elements, okay? For single elements. So oxide, nitride, sulfide. Okay, these are for single elements. The other two are for poly. Single element, and these are for poly. Okay, so that's the naming convention. Okay, and here they have examples of different polyatomic ions. Some of them you may have heard of: cyanide, chromate, chlorite, acetate, ammonium. Ammonia is a different. Ammonia and ammonium are two different things. Hydrogen carbonate. So here they have a bunch of different ones. So these are some examples. These are some examples. Okay. Most of the polyatomic ions are going to either end in "ites" or "ates." Okay. And when you see them in pairs, the one in "ite" is going to have less oxygen than the one with "ate." And what do I mean by that? Let's look at the table right here. So you're going to see a lot of similar pairs. So let me circle all the ones that are grouped. I would call this is one group. This is another. There are more than two, but they might not have all of them here. Here's another one. So this slide that we just passed right here, where the "ite" and "ate" pairs, it says the ion with fewer oxygen atoms will have the "ite" ending. They're referring to these. So here, for example, you have nitrites and you have nitrates. Notice how nitrite has two oxygens, the "ate" has three oxygens. Here you have chlorite, here you have chlorate. Notice how the one in "ite" has less oxygens. And then you have this last one, perchlorate. You won't see that too often, but this one has a fourth oxygen. Here you see nitrite, nitrate, and then you have sulfite and you have sulfate. So that's what they're referring to when they say that the "ite" ending is going to be the one with the less oxygens. And these are the three endings we were just talking about. Okay. This first one, again, is just for elements, and these are for the poly. Okay. These are for the poly. So now we'll get into the actual namings. It is not different from what you remember from the other sections. So it is always going to be the metal first, okay, like always. So here's the metal in this one. Here's the metal in this one. It's always going to be the metal first, okay? And now the only thing that's changing is instead of having one single element, for those of you that are wondering what ternary means, ternary just means three. So this is, we're writing formulas for compounds that now have three different elements now. But the three elements come from the polyatomic ions. So like always, again, metals come first. So let's do this one. Let's do this one as our example. So this would be calcium. And then all you have to do is just go to the table and look up what is the name for CO3. Go up to the table. CO3 is what? CO3 is carbonate. So this would be calcium carbonate. One thing to note is you have to look at the charges of the polyatomic ion. Okay. Notice how we only have one calcium. Why do we only have one calcium? We got to remember what is the charge on calcium. So calcium is in group 2, so it has 2 valence electrons that is going to give away. Carbonate, the table tells you the charges. Carbonate is -2. The whole thing is -2. This -2 is not with the oxygen, okay? So another thing to note is when you see the charges on these polyatomic ions, the charge is for the entire thing, okay? So the entire CO3 is -2, not just the oxygen, okay? The entire sulfate is -2 here, okay? The entire hydronium is +1, okay? So the charges are for the entire polyatomic ion. So carbonate is -2, calcium is +2. So they cancel out, you're good, okay? Let's do this one right here. Let's do the one with zinc. So Zn is zinc, and as you can see, we only have one zinc. So zinc. Why do we only have one zinc? Zinc, if I'm not mistaken, is +2. Zinc is one of those transition metals, but it only has one possible charge, and that charge is +2. No, it's not. I wanted to need the table next. And now we're looking for C2H3O2. What is that? C2H3O2 is acetate. And if you zoom in a little closer, it is -1. Remember, if you don't see a number, but you see a symbol, it's 1. So this is plus, but there's no number, that's +1. This is minus with no number, so it's -1. So acetate is -1. Zinc is +2. Zinc is +2. So zinc is +2 and acetate is -1. You need 2 acetates, which is why they have this 2 here. So this is zinc acetate. And let me explain the brackets that they have on there. So the name of this one, this is zinc acetate, okay? Remember, the metal comes first as always, and then all you have to put is just the name of whatever the polyatomic ion is. And you would just get that from the table. So you see that they have the whole acetate in brackets, and they have the 2 on the outside. Why are they doing that? So what that means is that you have 2 of that entire polyatomic ion, okay? So let me write it out the way we normally would. So zinc is +2. We know that. Acetate from the table, it just told us C2H3O2 this whole thing is -1. Remember, the charges need to cancel, so we're at +2 minus 1. That's +1. So we still need another negative. So we need a second of the entire polyatomic ion. Okay, we need a second one of the entire thing. Okay, the entire thing is -1. So now we have two of them. Okay, so +2 minus 1, now that's 0. And then how you would note that you have two of these is the same way you've done it before. So if you have two zincs, or if you have two sodiums, see how they put the 2 with the sodium? They just put it down there. But the only difference is, since the entire ion or the entire compound is negative, you need to write out the whole thing and put it in brackets like they do here. So you need to, if you want to show that we have two of them, you need to put the whole thing in brackets, close it, and then however many of them you have, you put that number here. So X can be any number. If you have 5 of them, you put 5. If you have 7, you put 7, so on and so forth. But that's how you show that you have more than one polyatomic ion. So let's say we wanted to add SO3 is sulfate, if I'm not mistaken. No, it's sulfite, my bad. So SO3 is sulfite. If we wanted to add a second one, you would have to put the thing in brackets and then put a 2 here. And that would show that now we have 2 of them. And that's how you do that. And then they continue with more examples. This is breaking down stuff you already know. So to write a formula, you got to figure out what the charge is from the metal, figure out what the charge is on the polyatomic ion, and just cancel them out. So if this is +1, this is -3. That means you need 3 lithiums, which is what you end up having here. Li3 and then PO4. They have the PO4 here in brackets. You don't need that if you only have one of them. They only have one PO4, so the brackets are not necessary. In this case, just know that. But they have them there anyway. And now let's do an example. So lithium chlorate. Lithium is Li +1. And then this what's the time here? Extend this too long. Okay, we're already at 12 minutes. So I'll do this one example and then I'll go to the sheet, the worksheet for today, and then I'll end it there. I don't want to make this video super lengthy, especially when it's stuff you've already seen. In terms of the naming, the only difference is now it's with polyatomic ions, which is just involves just come to the table and see what you have. So was it chlorate or chlorite? It's chlorate. Okay, so chlorate is this one, ClO3. And the charge on it is -1. So this is ClO3. And the charge on it is -1. So looking at the charges, +1, -1, they already cancel. There is no other work we need to do. So then the formula would just simply be LiClO3, done. Boom. That's your final answer. Okay, that is your final answer. And you can try these if you want. Remember, for transition metals, if you see this is telling you what the charge on it would be. So this is not magnesium, this is manganese. Okay, pages to the name, they look familiar, but they're not. This is magnesium right here, Mg. This is manganese, Mn. Okay, manganese, magnesium, two different elements. Okay, so now let's go to the worksheet. So today you're going to be doing this section, predicting and naming binary ionic compounds, but just with polyatomic ions. All right. So let's do one of each. There's only 2 types of questions. It's either going to ask you to write the formula or write the name. Let's do one of each. Sodium hydroxide. All right, let's do sodium hydroxide. So 42. Let's do number 42. I'm going to do it down here since I have space. Sodium is Na. And if you go to the periodic table, what group is it in? It is in group 1. So it only has 1 valence electron. So the charge on it would be +1. Hydroxide. Note, to answer these questions, you need to have those slides open because you need to have that table up. So let's go to the table. We are doing hydroxide. What is hydroxide? Hydroxide is right here. It is OH minus 1. So hydroxide, this would be OH minus 1. Look at the charges, plus 1, minus 1. They already cancel. There is no other work we need to do. So our final answer would just be NaOH. It's that simple. Just combine them, put them next to each other. What's the time here? Okay, we're at 15. All right, I'll do 2 formulas and I'll do 2 names. Let's do one that has a transition metal here. Lead 4 and phosphate. We are adding lead 4 and phosphate. So lead is Pb, okay? Lead is Pb. And I want to confirm that, yeah, right here. Lead is Pb. So we have Pb plus 4, okay? Remember that number in parentheses for the transition metals tells you what charge it is. And technically, to not to confuse some people, lead is not technically in the transition metal group. It would be considered what they call a post-transition metal. So see, you have transition metal, then you have post-transition. Lead would be considered a post-transition, but look where it is on the periodic table. It is pretty low. And because it's down here in group 6, it has a lot of rings. And because it has a lot of rings, it has the possibility of having more than one possible charge, which is why they have to put the Roman numeral in brackets to tell us which charge it is. So Pb is plus 4. And what is phosphates? Phosphate is PO4 minus 3. So now we also have PO4 minus 3. Okay, now remember to figure out what number goes with which, or how many you need of each. There are 2 ways to do it. You can do the addition method, which is where you add ions until the numbers finally cancel. The easiest way to do it, and I hope you've been doing it, is the cross method. Okay, so just with the arrows, cross the numbers. But remember, you always have to write the metal first. So lead, the metal comes first, then the second piece, which in this case is the polyatomic ion. Cross method. This one goes down here. This one goes down here. And if you do that, this is telling us that our final formula would be Pb. The 3 came down to the Pb, so this would be Pb3. And then, since we have more than one of the polyatomic ion, now I need the brackets. This would be PO4. And then we have 4 of them, so then you put 4. And this would be your final formula for number 44. So this would be PB3 and then PO44. Okay. And if you want to check your work, the charge on lead is positive 4. Positive 4 times 3 is positive 12. Okay. And then the charge on the PO4 is negative 3. And then negative 3 times 4 is negative 12. Okay. Positive 12, negative 12, they cancel, and you end up with a neutral ion. Okay. So that cross method is honestly the easiest method to use. You can use the addition method if you would like. Just make sure that whatever method you're using, the end goal is to have everything be neutral. And as long as that happens, you're good. If you're going to use the cross method, just make sure that you reduce. Okay, you need to make it as the simplest ratio as you can. There is no number that I can divide 3 and 4 by to give me a reduced ratio. But let's say we had lead 3 instead of lead 4. Okay, if we had lead 3 instead of lead 4, this wouldn't be a 4 here. This would be a 3 here. And if they're both 3, guess what? You can reduce this. You can divide both of them by 3, and then it would just become 1. And then this would be the correct formula. But this is not. This is just saying what would happen. But just remember to reduce if you can do that. All right. That's 2 names, or that's 2 formulas. I'll do a naming one, and this will be the last one, just to keep the video shorter than usual. Usually they go like 30 minutes. Let's do a naming one. What is the name of the compound whose formula? Actually, we did. That's actually I know the answer to that one. We did one of those already, so let's not do that one. Let's do 52. What is the name whose formula is MgCr2O7? Okay, so remember that the metal always comes first. What is Mg? Go to the table. If you don't know what Mg is off the top of your head, Mg is magnesium. So 52, first part of the name would be magnesium. And then for the second part, all you have to do is just go to the table and look up what Cr2O7 is. So this is magnesium. It's the first part. Go to the table. What is Cr2O7? Cr2O7 is this, dichromate. So the name would be magnesium dichromate. Okay. Magnesium dichromate, and that's your final answer. That's it. That would be magnesium dichromate. So for the naming, metal comes first, and then just look up on the slides what the name of the second one is. That's all you're doing for these. The technique is the same as the other ones. Again, by the other ones, I mean these. You guys did the simple version. You guys did the version with the transition metals. Okay, nothing is changing here. You still have to look at the charges. You got to make sure it's neutral. But everything is just on a table now. So just look up the table. What's the charge on it? What's the name of it? That's it. And this is specifically for polyatomic ion. There's more of them. These are not all the ones in the world. There are a lot more than these, but these are the ones that are the most common. So just for the naming, metal first, and then polyatomic ion second. And then when you're looking at the formulas, you just have to look at the charges. Remember, the valence electrons still apply. Again, the charges on the ions, the polyatomic ions, it's for the entire thing. So this whole thing is -2. This whole thing is +2. Okay, the charges are for the entire thing. And if you want to show that you have more than one, just remember to put it in brackets and put the number down as usual. Okay, that's all the tips I have for you. And best of luck. Hopefully this is on the shorter side. Yeah.